Hello, and welcome to another episode of Physics Chat. Physics Chat is a show where we talk to real-life physicists and ask them what it's like to be a modern-day physicist. I'm back with my lovely co-hosts, Fox and Sergi. On today's episode, we have Professor Adam Amara. How are you doing?
Doing very well. And the answer to your question is it's brilliant to be a physicist. Brilliant.
Amazing. Adam is the co-founder of the Euclid Space Mission, director of the Institute of Cosmology and Gravitation, and the chair of the UK Space Agency Science Programme Advisory Committee. Wow, that sounds like a busy life. Do you have any time for hobbies?
A little bit, thanks to my kids. So my favorite hobby is whatever they want to do, and they want to play computer games, they want to go to hobby shops. They keep me grounded, so I'm not, doing all of this all the time. In particular, we've gotten into, I don't know if you know StarCraft.
You must construct additional
So it's a real-time strategy game, and you build up resources and little armies, and you go off and fight each other.
Oh, that's amazing, and that's great to hear. Thank you so much for fitting us into your busy schedule. It's great to have you. And on today's episode, we're going to be talking about something a little different to our usual physics chat. We are going to be looking into the space sector. Fox, can you explain?
As you might be aware, most nations have a space sector. In the space sector, we design, create, and operate equipment and instruments in space. For example, satellites. Satellites are necessary for our modern day society, such as GPS. Mapping software is almost essential in a big new city. Anyway, in today's physics chat, we will be exploring everything from space mission design all the way to how we send satellites and telescopes into space. Talking of which, I hear you designed Euclid. Could you tell us a bit more about Euclid and your involvement in it?
Sure, yeah, very happy to. So I started working in Euclid, which will launch next year, straight out of my PhD. And I think related to your earlier question about what it's like to be a physicist and a scientist, there are many ways of doing it, and lots of people have different ways of thinking about this. The other nice thing about coming out of your PhD when you're young is you have no idea how hard things are. You have no idea. And it was a beautiful thing, as a young postdoc, I had no idea how difficult it is to design a space mission. And me and a friend were audacious enough to say, look, instead of taking data, why don't we sit down and figure out what it is we actually want and design our dream space mission? And we did. I could talk for hours, so maybe I'll just stop here and take questions.
No, that sounds amazing. But just to get an idea of how big the collaboration is nowadays, how many people are involved in Euclid today?
Well, let's build it up. So it started with a couple of scientists and a couple of engineers. So it was a very small team at the beginning. And then we grew it into a team that put in the proposal to the European Space Agency. I believe that year 75 proposals were submitted and we were ranked at the top. And by then, I think we'd grown to somewhere between 50 or 100 people. From that moment on, 2008, 2010 to now, it has grown to a collaboration of over 1,000 people. So it's a major international endeavor where if you think about astronomy as a whole, all astronomy is about 10,000 people. Euclid alone has 10% of all astronomers in the world in it.
Those are impressive numbers. So what exactly would be the process of building a space mission? If you were to start from, I guess, the start, what would be the building blocks that you would go through?
That's an excellent question. So I've been through several of these. They're called the process of coming up with a mission idea. Like you have a clear science question. The process of turning that into a mission, in some places they call it mission formulation, is really tricky because it's very complex. Space is very complex. And by that, I mean, it has a lot of components. You need to know the physics, but you need to know the engineering. You need to know about orbits. You need to know about how to download data. You need to know an awful lot of stuff. So it can be very complex. My vision is that just because something is complex doesn't mean it has to be complicated. And so segue into what we're doing here at Portsmouth, what I've been working on really hard this year is to try and build a facility, a national facility, so that anybody in the country, whether you're in a space lab or not, whether you're a scientist or an entrepreneur, if you have a good idea, the idea is you come to Portsmouth, we will find the experts that you need, we will pummel you with hard questions, and in only 2 weeks, we can do a first pass at a mission design. So the answer to your question is, if you have an idea, Fox, you come to us, and we'll walk you through and give you a mission design in 2 weeks. Does that answer your question?
Yeah, very good. Thank you.
So you mentioned that Euclid is supposed to launch next year, but I imagine you faced some issues. So could you explain some of those?
Oh yeah, wow. Over the history of the mission, there have been many ups and downs, many ups and downs, some technical, some to do, with all sorts of things. The most recent actually is to do with the Russian invasion of Ukraine. The reason is that the planned launch vehicle for Euclid was a Russian launcher, a Soyuz launcher. And after this invasion happened, ESA obviously cancelled all of those contracts. And so for the last year, we've been in limbo, not knowing how Euclid is going to be launched. We had a fallback plan, which is to launch on a rocket called an Ariane 6. But Ariane 6 is, new, needs to be demonstrated. And the other thing that happened this year is Amazon. Amazon came along and bought 18 launch slots, which put the entire program sort of, So the science community was very nervous throughout this year. Just recently, though, we've decided to go another way, go with the commercial launcher through SpaceX. So it looks like Euclid will launch on a Falcon 9. And if all of that goes through, which it looks like it will, then we're back on schedule, back able to launch summer of next year, which will be really exciting.
How do you stay motivated when you go through these downs when planning a space mission?
It's really hard. In fact, that's the thing I learned about space missions is the importance of being steady. Here's where leadership is important. You can have leaders that when things are going well, they get really excited, and when things go bad, they get really down. And the problem with that is it drives the entire team up and down, and it's extremely difficult because it's also a very intense environment. This is a £1 billion thing over many years. Careers are made from this. Science discoveries are on the line. So it's a very intense process. You'll always meet your target or just a bit under. And so you might as well aim high. So you need to be a little over optimistic all the time, no matter what's going on.
Thank you. That's really good advice. Thank you.
Very good advice for a PhD as well. Us three being PhD students.
Absolutely. PhD is another one of these very long, difficult, lots of stuck moments, and you've got to maintain your spirits all the way through.
These telescopes are sent up to retrieve data about the universe that we can study on the ground. What science do we hope to achieve through Euclid specifically?
Yeah. So the main driver that we push the mission on is dark energy. So dark energy is this mysterious force or effect that is pushing the universe apart. It's kind of ripping it apart, making it go faster and faster and faster. We have no mechanism in physics that really explains this. There are plenty of theories, but we don't really understand how this happens. And on top of that, the other major science driver is understanding dark matter. So dark matter is this mysterious substance in the universe that pulls everything together and clumps it. And even though in astronomy, we have now overwhelming evidence that there is dark matter and there is an effect that's ripping the universe faster and faster apart, we don't know what it is. And we've not seen these phenomena in any other part of physics, in fact, in any other part of human exploration. So Euclid is trying to shed light on those things. In the process, though, because we're going to collect very deep, high-resolution images over effectively the entire sky, the science that we can do is limitless. Now, with Euclid and another phenomenal experiment, the Rubin LSST survey, we are going to have tons of data sitting in hard drives. So astronomy is going to become more a question. Instead of looking to the sky, if you have an idea, you would first look to the archives and dig through the data to find interesting objects. So the honest answer is, even though we designed it around dark energy and dark matter, I actually don't know what the best science that'll come out of it. And that's pretty exciting.
Yeah, that's very cool. Okay, so if we're looking for dark matter and dark energy, how exactly are we looking for this?
There are many now ways of looking at the universe. We call each way of measuring the physical properties of the universe a probe. And Euclid and other surveys are now going to combine many probes to extract information to measure dark energy and dark matter. The one that I'm probably most excited about is around gravitational lensing. And massive objects like galaxies, they warp space-time so that light goes around it. And if you look very far deep into the universe, so galaxies that are 2/3 of the way out in the history of the universe, about 10 billion years out there, the light that travels from them has gone through an awful lot of stuff between it and us. And by carefully measuring the shapes of galaxies, billions of them, and carefully using a whole load of fancy statistical algorithms, you can actually extract and identify how the light has bent due to gravity. And in doing so, you measure the statistics of space-time and dark matter.
That's amazing. The fact that we can look 2/3 of the universe deep to start with is just mind-blowing. Yeah, very cool.
Yeah, I mean, that's why I love my job, how many people are lucky enough to think about this stuff?
Okay, now it's time for my random question.
Random
so Adam,
question.
if you could design any space mission, what would you choose and why?
I don't think that's a crazy question at all. That's literally what I do every day. I think one of the funnest is there's a mission concept over at NASA where they want to put a radio telescope on the far side of the moon. It's called the Lunar Crater Radio Telescope, LCRT. So the images you get of the sky in the 1950s and early 60s are amazing, are just absolutely mind-blowing because the sky is sort of clean. And then we as people started to use the radio for almost everything, right? Our mobile phones, communication. You can't get away from radio signals on Earth. Radio astronomy from Earth is becoming increasingly difficult. And so the best radio astronomy you'll do is you'll go to the far side of the moon, you block us off the Earth, and you look out into the cosmos.
That sounds amazing. So my random question wasn't so random then. So, Sergi, what about you?
Okay, space mission. Okay, let me think. I think also space is interesting because we can look back from space to the Earth and we can learn a lot from this perspective. And we have big problems on Earth today, one of them being climate change. So I think if I had the power to design and put forward the space mission, it would have to do something with climate change. So what about you, Fox?
Well, mine's another fun idea. Not quite as serious as climate change.
I was going to say mine is as well.
You get one satellite on one side of the Earth, or roughly, another satellite on the other side of the Earth. One has a laser, one has a spectrometer. You shoot the laser through the atmosphere and the spectrometer can pick up any aerosols or particles in the atmosphere. So you can measure aerosol distributions through the atmosphere. And I just liked the idea of satellites shooting lasers at each other. I just thought that was cool.
Amazing. I think mine's like yours, Fox. Very fun. I created the Susie Sat in an internship I did at a satellite company. And this was a low Earth orbit satellite. And essentially it was based around, because I'm a bit of a nosy character, it's spyware. Anyway, should we get back to the science?
You clearly have an amazing passion for space. And I just want to ask you, where does this come from? What is it about space that you find so interesting?
Well, I think what I like is, well, first of all, it comes from my mother was a Trekkie. So, it comes from growing up with Star Trek. Yeah, exactly. So I'm a TNG person. I grew up with the Next Generation. So that helps a lot. But it's great because you can do all sorts of things with space. You can help people navigate their daily lives. Every time you use Google Maps, you're using space technologies. You can monitor fields in remote countries to help farmers manage their crops. And you can look right at the edge of the universe where nobody else on Earth can look. So it enables all sorts of things. But fundamentally, to do the job, you need interdisciplinary teams. Everybody brings a different expertise. And the thermal engineer, the electronics engineer, the crazy, wacky theoretical physicist, they're all integral parts of this. And I think for me, that's what does it. You're driving technology, you're using things in ways that nobody really expected, and you're working with people that are much better at you. All sorts of things, but yet you can form a cohesive team that do things that seem crazy impossible.
So you've told us about Euclid, but what other projects are you involved in with the space sector?
Well, the space sector is very rich, and I think one thing I'd like to say is, in particular, if you're in the UK at the moment, it's particularly exciting. Last year, the government released a national space strategy, and it's the first time we've had a national space strategy. And flowing from that, the UK Space Agency is now launching a hugely ambitious set of programs. Now, anybody in the UK that has a science idea that wants to work with somebody from another country, be it France, be it Germany, be it the US, be it Japan, whatever, you've got a mechanism to propose that. And the UK Space Agency will walk you through. There are now dozens of new ideas being developed.
Yeah, that sounds amazing. And it does make the space sector sound very, very interesting.
Yeah, wow. Thank you so much for being on Physics Chat. It's been so interesting hearing about all space mission from Euclid. So I hope the one planned on the moon, and hopefully we'll get there one day. Thank you again for joining us, and let us know in the comments section, if you could design any space mission, what would you choose and why? We'd love to hear from you. Anyway, from everyone at Field of View, we hope you have an amazing day, and goodbye. Bye.
Bye. Just because something is complex doesn't mean it has to be complicated.